Hello, discrete math fans. Let's try this problem. We're going to try to find the smallest positive integer n so that 8 factorial times n is a perfect square. Now before we get started with this, let's talk a little bit about what we know about perfect squares and unique factorization. Let's suppose that m is a perfect square. That means that we can write m equal to s squared for some integer s. Now, the fundamental theorem of arithmetic tells us that there is a factorization of s into primes, and that this factorization is unique. So now we can say that m is equal to s squared, and then we'll rewrite that with our primes. So that looks like p1 e1 times p2 e2 all the way down to pk to the ek, and that whole thing is squared. So then we can take that square, since it's on top of a product, we can distribute that square onto each piece. So that's p1 to the 2e1 times p2 to the 2e2, and so on down to pk to the 2ek. The important thing here is that if we take a perfect square and write down its unique factorization into primes, it's going to have a factorization where the exponents are all even numbers. And that's a fact that we're going to keep in mind through the rest of this problem. So now let's take 8 factorial and factor it. Remember what 8 factorial means. It's just the product of the first 8 integers. And then we'll decompose this into primes. So notice, for instance, that this 6 right here got turned into 2 times 3. This 8 got turned into 2 times 2 times 2. So we've just decomposed this as a product of primes. And then we clean it up and write this thing in standard factored form. So we have 2 to the 7th times 3 squared times 5 to the 1st times 7 to the 1st. Now let's turn our attention to 8 factorial times n. And we want this to be a perfect square. So the smallest value of n that would work would be 2 times 5 times 7. Because that would make it so that if we multiplied everything together in here, we would get all even exponents on our primes. So in that case, 8 factorial times n would be 2 to the 8th times 3 squared times 5 squared times 7 squared. And as we saw before, that's going to be a perfect square. So this number here, 70, is the smallest number that would work. Okay, that's all for now.